The identity matrix is a square matrix that, when multiplied by matrix A, equals matrix A. Okay, and so if you notice, the identity matrix is symbolized by I. So I have A times I equals A. It's kind of similar to what number? 1. I mean, that's what the identity matrix is similar to. And so here are the identity matrices for a 2 by 2 and a 3 by 3. Okay, has to be a square matrix. And so if you notice, ones are along the diagonal, and then everything else is zeros. So that's what the identity matrix is. And so today we're going to talk about inverse matrices. And inverse matrices, if you notice, they're defined as two matrices. They're inverses of each other if their product is the identity matrix. So when I multiply two matrices together, I get that matrix that had ones along the diagonal and zeros everywhere else. Okay, so we're going to look at whether or not these two matrices are inverses. So what I'm going to have to do is multiply them together. Okay, so remember how I multiply. First of all, I have to check. These are both 2 by 2s. So can I multiply them together? Yeah, and I'm going to get a 2 by 2. Good. So I'm going to start with row 1, and I'm going to take that times column 1. Okay, so row 1 times column 1. So really, I've got -4 times 1/4 plus 2 times 1/2. Okay, and then I've got row 1 times column 2, which is -4 times -1/2 plus 2 times -1. Now I'm going to go ahead and do row 2, column 1, which will give me -2 times 1/4 plus 1 times 1/2. And then last but not least, I'm going to have row 2 times column 2. So -2 times -1/2 plus 1 times -1. So now let's go ahead and -4 times 1/4 is what? -1 plus, what is 2 times 1/2? 1. Okay, what do I get here? What's -4 times -1/2? 2 plus -2. What's -2 times 1/4? -1/2 plus 1/2. And then what is -2 times -1/2? 1 plus -1. So if I add those together, what is my resulting matrix? So are these inverses? Okay. Questions? We're going to go ahead and look at another one. Okay? So you should go ahead and have on your sheet what the other one is. So in this one, I'm going to take row 1 times column 1. So 3 times 3/4 plus -5 times 1/4. Okay? 3 times 3/4 plus -5 times 1/4. And then I'm going to take 3 times what? 3 times 5/8 plus -5 times 3/8. My next one will be -2 times 3/4 plus 6 times 1/4. And then last but not least, I've got Negative 2 times what? 5/8, yep, plus. Right. Now I'm going to show you a little trick here. I know some of you are probably going to be typing these in on your calculator, and that's fine and good. Okay? I'm not going to do that per se. I'm going to try and keep everything with the same denominators. So here I'm going to take 3 times 3, which is, and I'm going to put that over 4. So I really get 9/4 plus, what's negative 5 times 1? So basically I have 9/4 plus negative 5/4. What is that going to give me? 4/4, which is 1. Okay? On this next one, 3 times 5/8. So I'm going to take 3 times 5 and get 15/8. Okay? Then I'm going to take negative 5 times 3 and get negative 15. So when you add those together, what do you get? 0. Okay? Down here, I'm going to take negative 2 times 3 and get negative 6/4. Then I get 6 times 1, which is, so what do you get when you add those together? 0. Here, negative 2 times 5. Negative 10/8. 6 times 3. 18/8. You add them together, and what do you get? 8/8, which is, so are these inverses? Yes. Questions? All right, so we already know how to find out if two matrices are inverses of each other. Now we're going to find out how we can actually find the inverse of a 2 by 2 matrix. And so on your sheet, it says if A equals A, B, C, D, so it's got to be a square matrix, 2 by 2, then the inverse of A equals 1 over AD minus BC. Okay, and then this next one's going to look a little weird. Look at how we've switched some things around. Okay, so basically, this is the easy way to figure out what you're doing. I want you to compare this right here with my original one right here. Okay, now I'm going to start in the top left. What I'm going to do on that first diagonal, on this diagonal right here, I'm going to switch spots. So notice how we've switched spots. Then on the other diagonal, I'm going to switch signs. So I want you to remember that little saying, switch spots, switch signs. And that'll help you write the inverse. Switch spots, switch signs. Now this here is looking kind of familiar. This is actually the determinant of A. And so you will actually see it written sometimes as just 1 over the determinant of A. So let's go ahead and look at an example. It says find the inverse matrix if it exists. Now it wouldn't exist if the determinant is 0. So if you find the determinant to be 0, you can go ahead and stop. So let's go ahead and find the determinant of P. The determinant of P is A times D. So in this case, 7 times negative 1 minus B times C. That's that AD minus BC. So what is 7 times negative 1? Negative 7 minus, what? Negative 10. So what does your determinant come out to be? 3. So now I got to find the inverse. The inverse will be 1/3. Okay, now we got to remember our little saying, switch spots. So if I switch spots, what do I do? What will I start with up here? 7. So I switch spots first. Now on the other diagonal, what am I going to switch? Signs. So this one becomes, and this one becomes. So the final thing I'm going to do is distribute the 1/3. You're going to find when you find the inverse matrix, you're going to get fractions quite a bit of the time. You're going to get weird, kind of weird numbers. That doesn't mean you've done them wrong. So this inverse is actually negative 1/3 5/3, negative 2/3, and 7/3. All right, let's go and look at another one. Find the inverse. So very first thing you need to find is what? Determinant. So the determinant of Q, AD. Yep, so basically I'm going to just go ahead and write out this way. Minus negative 6 times 12. So what is negative 8 times 9? Negative 72 minus negative 72. What do you end up getting? 0. So this is what you write. No inverse. Okay. Some places you will see it written no inverse exists. Okay, if you write no inverse, that's fine for me. Okay, so that's the thing. If you ever get 0, like in that case, you're done. So let's look at the next one. Okay, so the next one, the determinant of Q. What do I take? 2 times 3, which is 6 minus negative 4. So my determinant is 10. So I'm going to take 1/10 times. Okay, let's remember our saying. Switch what?
Spots.
Switch spots. So what will be up here in the top left? 3. What's in the bottom right? 2. So I've switched spots. Now what do I need to do? Switch signs. So upper right is negative 1 and 4. So the final step I need to do is go ahead and distribute that 1/10. So my answer will be 3/10, negative 1/10, 2/5, yep, and then 1/5. Make sure you reduce those bottom 2 down. If some of you are saying, whoa, 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 wait, that's 4/10. It is, okay, but you need to reduce that down. Same thing with 2/10 on the bottom. Okay. The final thing we're going to talk about in this section is solving matrix equations. Okay, one of the things we learned about matrix equations is that they don't always play nice. It's not like the typical addition, subtraction, multiplication, division that we've done before.
Of course not.
And so, if I want to solve this for x, okay, I can't divide by a. You can't divide with matrices. But what you can do is use the inverse. So what I'm going to do here is I'm going to multiply by the inverse of a. So basically, I'm going to multiply by the inverse of a. Now, if I do that on the left side of a, I got to do it on the left side of b. So there's no division. So if you were ever going to divide, you multiply by the inverse. Okay, that's kind of a little trick that you can think of. So here, those cancel, and I'm left with x, and that equals a inverse b. All right, let's look at this next one. What do you think you would do to solve for x? You think you would normally divide by b, but we can't divide. So the first thing when you think divide by b, that means inverse. So I'm going to take xb times b inverse. Now notice where I had to put b inverse. It has to be right next to the one it is getting rid of. It's canceling out. So on the right side, I get a times b inverse. So your final answer here will be x equals a times b inverse. What are you going to do on that third one? Add c first. Very good. So I end up having bx equals a plus c. Yeah, now you think you should divide by b, but you know we can't. So we're going to do the inverse instead. So where am I going to put the inverse? Before b. Yep, I'm going to put it right here. And so where am I going to put b over here on the right? Got to put it before. So you're going to have to do some parentheses. Okay, so really x equals b inverse, and then you have your parentheses. Okay, now you're probably wondering why on earth did we even look at that? And the reason is because the final two problems we're going to look at today actually deal with this. Okay? Okay, here we go. Use a matrix equation to solve a system of equations. Okay? Now, this isn't bad at all. I'll be honest with you. You can handle this. What I want you to do is I want you to look at the left side of the equation. And based on that, I want you to write a matrix just with the numbers. What would it be?
2, 3, 6.
Okay, good. 1, 2, 3, negative 6. Okay, now what I'm going to do here is I'm going to put an x and a y. Reason being, that's kind of how we are going to solve this matrix, is we've got to put some sort of variables, and here's where my variables go. And then on the right side, my matrix will be 9, 3. This is real similar to the problem we just looked at that looked like this. It's the exact same thing. You just got done writing that down on the previous slide. How did I solve this? I took the inverse over here, right? And the inverse over here. So basically what that means is I need to find the inverse of this matrix. When I get the inverse of that matrix, I'm going to take it times the matrix on the right. Okay? So let's go to find the matrix. Very first thing you need to find is the determinant. Okay, the determinant in this case will be 1 times negative 6 minus 2 times 3. Yep. 1 times negative 6 is negative 6. Minus 2 times 3 is 6. So the determinant is negative 12. So notice I've got 1 over negative 12. Switch spots means 1, and then switch signs. Negative 2, negative 3. So now you've basically got to distribute that negative 1/12. And so when I distribute that, what is negative 1/12 times negative 6? 1/2. What is negative 1/12 times negative 2? 1/6. 1/4, and then negative 1/12. So that's the inverse, right? So what am I going to take that inverse times? I'm going to take it times 9, 3. Okay. So we're about done. I'm going to take this times this. Okay? So 1/2 times 9 plus 1/6 times 3. And then I'm going to take 1/4 times 9 plus negative 1/12 times 3. And those are going to be my two answers, believe it or not. The top one is going to be what x equals. The bottom one is going to be what y equals. So, what's 1/2 times 9? 9 halves. 1/6 times 3. 1/2. So what is 9 halves plus 1/2? 10 halves, which is 5. Okay. What's 1/4 times 9? 9/4. What's negative 1/12 times 3? Negative 1/4, right? Negative 3/12. So what's 9 and negative 1? Negative 8/4, which is negative 2. So your ordered pair, 5 -2. Now, is this the easiest way to solve this system of equations? No, it's not. It's just another way. Okay, I mean, yeah, you could use elimination and substitution, probably get done way quicker. Totally get that, totally understand that, but this is just another way to solve using matrix equations. Okay.
What's the point with
Because you can solve bigger equations. And generally you can use technology, like we're going to use technology, we're going to do something known as reduced row echelon form on Thursday, which is another way to solve the system of equations. And you'll use the netbooks to do that. Okay, so on page 202, okay, I'm going to actually go ahead and skip that next example. On page 202, 13 through 25, okay, 28 through 34 are the evens. All right, so 13 through 25, 28 through 34 are the evens. So those of you that are here tomorrow, you guys have study time. Those of you that are one acting, you probably better find some time to get this done or get it done tonight. Okay, Thursday, the plan is we will check this and the assignment you were given yesterday. And then Thursday we're going to work on GeoGebra and I'm going to show you something known as reduced row echelon form that you will be tested on your test. Friday we're reviewing. Next Monday and Tuesday is your test. Okay? Yes, the evens are just for the 28 through the 34. 13 through 25 is off.